Assalamualaikum and hi everyone. Let's proceed to the next subtopic for chapter 1, which are line integral, surface integral and volume integral. And in today's lesson, you will learn 1.5 line integral. Okay, line integral is the integral of the function f(x,y,z) that is evaluated along the curve C. And the line integral can be evaluated in scalar field. Okay, for example, if fx is density, then line integral gives you the mass. If the line integral is evaluated in the vector field, then we can obtain the amount of work done by the particles that move along the curve C. Okay, simple integration can give you the area under the graph. So let's say we have this integration. Okay, we integrate the function of fx, this fx, from a to b. Then you can get this area under the graph. Okay, for line integral C, okay, this curve C is called path of integration from a to b. Line integral will give you the area above this curve and under the function f. Okay, let's look at the definition of line integral. Okay, a line integral of vector f over a curve C, where this C is represented by RT, is defined by this formula. Okay, f integrate f dot dr. So this is dot product. Okay, equal to, so you just substitute vector f here, component of vector f, and also dr, and then perform dot product. So this formula equal to this formula. Okay, this is the figure for line integral. So here C refer to the path of integration. Okay, and this RT is the parametric representation of curve C. Okay, let's look at how to do parametric representation of curve C. Basically, we want to represent curve C by RT. So look at this table. So we have different types of curve. Okay, the first column is types of curve, and the second column is the parameterization. Okay, look at this example 1. If the curve is line segment, okay, from this point to this point, then you can refer this row. So RT is given by this formula. 1 minus t multiplied with the first point plus t multiplied with the second point. So for this example, RT equal to 1 minus t multiplied with vector. Alright, vector, you change from point to vector 420 plus t multiplied with vector 463, and then solve. Okay, multiply vector with 1 minus t, you will get 4 minus 4t, 2 minus 2t, 0 multiply with 1 minus t is 0. Okay, plus 40, 60 and 3t. Okay, and then you plus the vectors. So remember, RT is vector. Okay, look at example 2. Particle moves in the counterclockwise around the circle. So the curve C for this question is circle. So you can refer the first row. And in the direction of counterclockwise. So you can refer this formula. So R equal to X equal to R cos t, Y equal to R sin t, and t is from 0 to 2 pi. So this limit is for one circle, one complete circle. Okay, so for this question, x square plus y square equal to 1. You can write this as 1 square. R equal to 1. R is the radius of circle. Okay, R equal to 1. So substitute in the formula for x and y. So we have x equal to cos t because R equal to 1. So y equal to sin t. Okay, how about the limit? For this question, the particle move from point A to B only. So A is 1, A is here, 1, 0, and B is here, 0, 1. So the particle move from A to B only. So T, so value of T is from 0 to pi over 2 only. So pi over 2 equal to 90 degrees. So this is 90 degree. So RT equal to X, Y, and Z. So RT equal to X, Y, Z. So X for this question is cos t. So cos t. Y is sin t. And Z equal to 0. So this is the parametric representation of curve C for circle. Okay, for example 3, evaluate the line integral along the parabola y equal to x square. So when you see the table, you can use this last row. Y equal to fx. So y equal to x square. So the parameterization is x equal to t. Okay, let x equal to t. Y equal to fx. So y equal to, okay, substitute x equal to t in the function. Okay, so y equal to x now is t. So t square. So y equal to t square. RT equal to xy. So x equal to t, y equal to t square. And remember, R is in the form of vector. Okay, line integral is given by this formula. See, vector f dot product with dr. Okay, basically we want to change all these three terms. Okay, change all to t in terms of t. Okay, the first step is to find dr. So to find dr, you must first find rt. Okay, rt sometimes given in the question, or you can find in the table. Okay, the second step is to find ft. Okay, from the question you change to ft. Okay, and step number 3 is to find the limit of t. Okay, from c you change to t0 to t1. So we want to find this t0 and t1 from the question or from the points. Okay, so basically to find line integral, you must have these three components. Okay, dr, f, and also the integration. or the limit. Okay, first determine RT. Okay, look at question 1. Given F, okay, given vector F and R is the line segment. So we know that R is not given. You must calculate using the table. So step number 1 is here. You calculate from the table. Calculate RT. Okay, so second is F, and third one to find limit of T0 and T1. Okay, you can find using these points. Question 2. Given vector F and C is the curve represented by R equal to, okay, for this question, R is given. So no need to calculate. So this is 1. Okay, second is vector F. And last one is the limit. Okay, the limit also is given for this question. So this is step number 3. So T0 equal to 1, T1 equal to 2. Okay, number 3. Okay, given vector F and RT from, okay, these 2 points. First, RT is given. Okay, second, vector F. And third one, the limit. Okay, for this question, you must calculate the limit to find T0 and T1. Okay, and the rest, you can refer to the lecture notes. Okay, let's look at the first example for line integral. Okay, calculate integration of f dot dr. So this is the line integral. Okay, the formula for line integral. If vector f given by xy and c is the curve represented by parametric equation RT from these 2 points. Okay, so line integral is given by this formula f dot dr. Okay, the first step is to find dr. Then second ft. Then the third step is to find the limit. And then last one, integrate. To calculate dr, okay, you must find RT. Okay. For this question, RT is given. RT equal to vector t square t cube. Okay, so dr over dt equal to, okay, differentiate r to t, you will get 2t and 3t square. And we want dr equal to, okay, put dt here on the right side. So you will get 2t 3t square dt. Okay, from RT, you can find value of x and also y. Because RT equal to xy, x and yt. So xt equal to t square. Here, this is x and this is y. So y equal to t cube. Step number 2, find ft. So from question, okay, vector of f equal to xy. Okay, here xy. And then we want to find ft. Okay, change x and y to t. So we know that, okay, from step 1, okay, we know that x equal to t square. So t square, y is t cube. Next, step number 3, find the limit. Okay, find t0 and also t1. For this question, okay, you can find t0 to t1 using these points. So at 0.48, so this is x and y. Okay, x and y, x is given by t square. So t square equal to this x is 4. Okay, and t cube equal to 8. Okay, for the starting point, you can get t0. So t0 equal to the square root of 4 is 2. Okay, T naught is 2. Okay, at second point, 9, 27, you can find T1. Okay, we want to find T naught and T1. So, just write T square here. T square equal to 9. T cube equal to 27. Okay. So, T1 equal to, T equal to square root 9 equal to 3. And step number 4, calculate the integration. So, f dot dr, okay, equal to, okay, the integration is from 2 to 3. F here is ft. Okay, ft. Okay, dot product with dr. dr is here. 2t, 3t square, dt. So basically we change this formula to t. And then solve for dot product first. Okay, multiply the same component. You will get 2t cube plus t cube multiply with 3t square. So 3t power of 5 dt. Okay, and then integrate, we'll get 2 3 power 4 over 4 plus 3 t power 6 over 6. Okay, from 2 until 3. So substitute. Okay, simplify. The final answer is 365. For second example, compute the line integral where C is the line segment. Okay, from this point to point 463. And vector of f is given by this vector. Okay, we want to find f dot dr. Okay, so the first step is to find dr. You must find RT first. Okay, then FT. After that, limit of T0 to T1. For this question, RT is not given. So you must calculate RT. Okay, for line segment. Okay, you can refer to the previous lesson about parameterization. So from table, RT equal to, okay, RT is given by this formula 1 minus T, okay, vector of 4, this is the starting point, plus T multiply with the second point, okay, 4 6 3. Then multiply 1 minus T with the vector and solve the rest. So RT is given by this vector. Okay, simplify. And we know that this is X, Y, and Z. Okay, X equal to 4, Y equal to 2 plus 4T, Z equal to 3T. And then find R. R equal to, okay, differentiate R to T, we get 0, 4, 3, dt. Okay, this is the R. Step number 2, find FT. So from question, vector of f equal to z negative y x. Okay, here. So vector of ft, okay, using these values, z equal to 3t. So 3t negative y is 2 plus 40, x is 4. Then simplify. Okay, this is ft. Third step is to find the limit. You can find the limit by using the points. At 402, the starting point. Yeah, this is x, y, and z. Our x here is 4. 4 equal to 4. This 4. And then y. Y is 2 plus 40 equal to 2. And then z. Z is 3t. 3t equal to 0. So t naught equal to 0. Okay. At second point, 4, 6, 3. 4 equal to 4. 2 plus 40 equal to 6. 3t equal to 3. So t1 equal to 1. 1. And last step, okay, calculate the integration. Let's see, f dot dr. Okay, substitute. Now we have t naught until t1. So t naught is 0 to 1. Okay, vector of f. ft is here. 3t negative 2 minus 44 dot product with dr. dr is here. 0, 4, 3 kt. Okay, then solve dot product first. You get 3t multiply with 0, you get 0 plus 4 multiply with this term. So we get negative 8 minus 16t and then plus 4 multiply with 3, 12. Okay, then integrate. You will get simplify and integrate. Okay, you will get the final answer is negative 4. For example 3, find the work done if vector F is the force field on a particle that moves in the counterclockwise around the circle. Okay, around the circle, this particle move from point A to point B. So work done here refer to line integral. So line integral is given by this formula. Okay. For first step, you have to find dr here. So r here is the parameterization of circle. Okay. Refer to the table that we have discussed before. So for this example, okay, x, y, z is given by this formula. And then, okay, substitute r. Okay, r equal to 1, okay, in the formula, and you will get value for rt. X here, x equal to cos t, y equal to sin t, and z equal to 0. And then calculate for dr, differentiate r to t, then we get this answer. So this dr given by this formula. And step number 2, find ft. So this is from question f given by this vector. And then we want to find t, ft. So substitute x, y, z in terms of t in this vector. Then we'll get this answer. Okay, step number 3. Okay, we want to find the limit. The limit for t0 in t1. Okay, for this question, you must draw the graph because the particle move from A to point B only, not fully one circle. So t here, the limit of t is from 0. Okay, 0 move to 90 degrees. So 0 to pi over 2. And last one, step number 4. Okay, last one, substitute r, f, and also the limit in formula. And you perform dot product. Okay, integration for this equation, you can look here, you can refer here. Okay, integration by substitution. And then the final answer will be -2. In today's lesson, you have learned about line integral. Okay, line integral given by this formula. Okay, integration of curve C of vector f dot product with dr. Where this r, okay, rt is the parametric representation of curve C. First step is to find RT. And then find dr. Okay, second step, find ft. Okay, and third step is to find the limit of t0 and also t1. And last one, substitute all, find the integration. So that's all for today's lesson. Thank you guys.